So in this next case, you've been told the sum of three consecutive terms of an arithmetic progression is 9, and their product is 20.25, isn't it? You've been told to determine the three terms. So the first thing you need to know is that you've been told it is an arithmetic progression, isn't it? So in an arithmetic progression, you know there's a common difference adding, isn't it? The first term is denoted by A. The first term is denoted by A, and we have the common difference D. So when we talk of consecutive terms, there are those terms which follow each other, isn't it? So we now have the first term, isn't it? The second term and the third term. It doesn't matter the portion where you extracted it. That portion where you've extracted it is what you make the first, second, and third term, because they are consecutive following the order of an AP, isn't it? Are we together? So the first term is denoted by. So for you to get the second term, it is usage addition. A plus D, the second term is, and your third term will be AD plus D will be A plus 2D. So from there you can see the nth term of a geometric progression. The third term it is plus 2D. So it is 3 minus 1, n minus 1, isn't it? So the nth term of an AP, an arithmetic progression, is A plus n minus 1 into D. If n is 3 minus 1, you get 2D. If n is 2 minus 1, you get 1D, isn't it? Are we together? So that is how to get the nth term. So we have the three consecutive terms. So you go back to the question. The sum of the three consecutive terms, the sum, meaning if you add these three consecutive terms, what do you get? 9. So if I add the three consecutive terms, the first term plus the second term plus the third 2D plus the third term, I get 9. That sum, I've been told, is 9. And their product is 20.25. Their product, meaning if I multiply these three terms, if I multiply them, A times A plus D times A plus 2D, I'm supposed to get 20.25. So I have two equations, isn't it? So I solve those two equations to get the value of A and D. So once I get the value of A and D, I come and substitute those values here to determine the three terms, isn't it? Yes. Are we together? So let us start by simplifying the first one. A plus A is 3A. D plus 2D plus 3D is equals to 9. So 3 is a common factor, isn't it? If you divide all through by 3, you get A plus D. A plus D is equals to 3. Is equals to 3, isn't it? So this is the equation 1, isn't it? Now equation 2, we can start by the first bracket here. A multiplies everything inside this bracket, isn't it? A times A plus A times D, AD. We are done there, isn't it? So we are now remaining with a product of two brackets, this and this. Is that okay? Yes. Now, from here, to make your work easier, we can just expand the whole of it at once. So we start again. A squared multiplies everything on the other side, isn't it? So move A squared times A squared times 2D plus 2A squared D. I'm done with this, isn't it? Then you go again. Positive AD is just AD, isn't it? AD multiplies everything on the other side. AD times AD times A squared D, then AD times 2D plus 2AD is equals to 20.25, isn't it? But again, look at this. You see, sometimes when you are also very observative, sometimes you also need to be very observative. When you are very observative, you see this is the step you will be moving in, isn't it? But now somebody who is very observative, look at this. Anywhere you see A plus D, you put what? Are you seeing that one will simplify that? So that you remain with the equation which is very condensed, isn't it? Are you seeing it? Because our aim here is to work with an equation which is as simple as possible. This one will give you the answer yes after getting this, where you can make either A or B the subject of the formula, then you substitute here. Then you remain with one value, isn't it? Yes. Then from one value you can, when you substituted maybe D, you will remain with everything to be A. Then you work the value of it. But you see, you will be going a very long process, isn't it? To get something which ought to have been very simple if you manipulated, isn't it? So if you look at this case, this equation A plus D is equals to 3. It means in this second equation here, where there is A plus D you put, will make it simpler, isn't it? Yes. So this is how you do it. That is Roman 1. So we want to put A plus D. Here we have A into A plus D into A plus D plus D is equals to 20 point. So this is A plus 2D. See, I want A plus D from A plus 2D. So that is A plus D plus D. Yes. So that here now I have A, my A plus D from this equation is 3. Where there is this A plus D, I put what? 3. Then where there is this A plus D, I put what? 3. So I will have 3 plus D. Isn't it? Yes. I will have 3 plus D to be equals to what? You must always look for a means of making a question to look simpler. You can as well solve it with another method, but that is a whole century solution because you will be in a higher order, a cubic. So when it is cubic, it means you will be using either remainder theorem or factor theorem to get the roots, isn't it? And if the remainder theorems and factor theorems are not getting you any root, it's wasting your time, then you will go with the numerical iteration methods. So you see all those long processes can easily be eliminated by just substituting this equation in the other one, isn't it? Are we together? So what do we have here? A times 3. Or what you can do is to divide both sides by 3, isn't it? To remove this 3. Send it up. Because this is multiplication of this times this times this. You can do anything. I can divide both sides by 3. Always look for a simple mean. So this 3 goes with this 3, isn't it? I remain with A into 3 plus D to be equals to, because I've already looked there, 2 plus 5 is 9. I know this number is divisible by 3. You know the divisibility test. You have to move with all the tools in mind when you are solving this kind of problems, isn't it? What do you have? 6.75. Are we together? So we have A into 3 plus B is equals to 6.75. So we've done the first substitution. We now do the second. The second substitution is now you make either A or D the subject of the formula and you substitute, yeah, isn't it? Because you have to remain with either A or B to solve, isn't it? So make either A or B the subject of the formula, then you substitute in this equation. Are we together? We've used it to simplify this equation so that this is now our equation too. So in the end, it means we have these two equations we now want to solve, isn't it? Are we together? So start. Which one do you want to make the subject? A. So if you make A the subject, it will be? A is equal to 3 minus D. So D goes to the other side, A is equal to 3 minus D. And this is our equation. We have A into 3 plus D is equals to 6 point. So where there is A, you put the value of A, which is 3 minus D. So here is 3 minus D into 3 plus D is equals to 6.75. What is this? That is a difference of 2 squares. Quadratic. This is a difference of 2 squares. Remember, the quadratic third identity. If you have A plus B into A minus B, see that is a difference of 2 squares. A square minus B square. Isn't it? So here it means our A is 3, our D is B. So it means that is going to be 3 squared minus is equals to 6.75. You just be observative, isn't it? If you're not able to see that, you simply expand. 3 times 3 is 3 squared. 3 times positive D plus 3D minus D times 3 minus 3D minus D times D minus D squared, isn't it? So you can see this and this cancels out. You remain with 3 squared minus D squared. A difference of 2 squares, isn't it? To be equals to 6.75. So that cancels out with that. You remain with 3 squared is 9 minus d squared is equals to 6.75, isn't it? So what do you get? D squared goes to the other side, it becomes positive, isn't it? So here we'll have 9 minus 6.75 is equals to d squared. Is that okay? Okay? So 9 minus 6.75 is 2.25 is equals to d squared. So for you to get d, you get the square root on both sides, isn't it? Yes. So look for the square root to get d. 1.5. It is plus or minus 1.5, isn't it? But now you look there, you were told the sum of the three consecutive terms is 9. Meaning when you take that d to be negative, it is very... No, you never know, because we don't find the first term. Either both of them can work. It's only that when you take d to be negative, you will, starting with a bigger number followed by a smaller, but at the end they will still be seeing them to be those three terms. It can be something like, if they were 10, 9, and 8, when you take d to be negative, they will appear like this. When you take d to be positive, they will appear like that. But they are the same three numbers. Are you getting the idea here? Yes. Are we together? So it means d is plus or minus 1.5. So you use either. Either will mean we'll start with, we'll just put them like this. We'll just toggle them, isn't it? Yes. But the three numbers is what you are interested in, isn't it? Are we together? Yes. Good. So you looked for that square root to get d, and you found d is 1.5. So after getting d, can we now get a? A is 3 minus d, isn't it? 3 minus 1.5 is 1.5. So you found a and d. So you've seen how to solve simultaneous equation by making it in simplest form. So we have our a to be 1.5 and our d we've also found to be 1.5. Meaning, when you took d to be negative 1.5, you will get a to be 4.5. Isn't it? Meaning you will be starting from 4.5, 3, 1.5. And the other one will be starting from 1.5, 3, 4.5. Then you see they're the same three terms. Are you seeing that? So here we have our a and d. So the three consecutive terms was the first term which was given by a, and the second term which was now a plus d, and the third and the third term which is a plus 2d. So what do we get? Substitute. A is 1.5. A plus d, 1.5 plus 1.5? 3. A plus 2d, 4.5. So it implies that the three terms is 1.5, 3, and 4.5. Those are the three consecutive terms. So we are not interested whether it was an decreasing or an increasing. What we are interested in those three consecutive terms, isn't it? Are we together? Good. So those are the three consecutive terms. So let us check another case.